All right, here we have 8.3, the first set of notes for those. All right, so our goal today will be to evaluate log functions. The first thing is, what is a logarithm? It's actually the inverse to an exponential equation. So these two statements here, this log base b of x is how you'd say that, log base b, so whatever, it's a subunit there, so it's a smaller version, and then that x is a normal letter or variable in this case. So log base b of x equals y. This would be converted, if you would say, as the base is b. Remember, log base b, so your base is b. Your exponent is y, and that will equal x. Okay, so these are actually equivalent. Okay, so what we can do then is we're just going to work on these first four problems. I just want to convert. So our base here, remember, it's log base 2. So our base is 2. The exponent is 3. And that equals 8. And you can see 2 to the third power equals 8, which is why the log base 2 of 8 is equal to 3. So in number 2, what is the base? We look. This number here is 4. So our base is 4 raised to the power of whatever the answer says. So in this case, negative 4 is equal to 1 over 256. And again, you can check those because 4 to the negative 4th power is 1 over 256. You can kind of see if you are converting those correctly. Numbers 3 and 4, we're going to convert back to the other way. So we're going to convert to a logarithm here. So in this case, we have log. What's our base? Base of the exponent is 4. So that's your subunit, log base 4 of 64 is equal to, remember the answer here was the exponent, so it's 3. All right, so then the next one, again, this is another logarithm. What's your base? Is 125 of 5 equals the exponent, which was x. Okay, so all I'm asking you to do is to convert. That's a really big thing for what we're going to be doing in the second set of notes for 8.3. So really all we're going to focus on is converting and then some review stuff. So we can evaluate logarithms, and the way that we're going to do this is just by converting each of these. So pretend these all equal x, because when you're evaluating, you're figuring out the value of it. So we'll say it equals x. So then what you're going to do is you can convert. So we have 3 to the power of x is equal to 81. And then the way that you're going to solve that is just like we did in 8.2, where you want to find a common base. Find a common base between 3 and 81. That common base would be 3. So we have 3 to the power of x is equal to 3 to the power of 3. 3 to the power of 4. Now that you have the same base, you can set the exponents equal to each other. So x and 4, and x equals 4. So that means that log base 3 of 81 equals 4. That is your answer. That's what you were looking for. Okay. So now we're going to do it again. So again, the first thing you're going to do is you're going to convert. 8 to the power of x is equal to 32. We need to find a common base between 8 and 32. That common base should be 2. So this is 2 to the 3rd power. This is 2 to the 5th power. Guess we didn't need parentheses there. Uh, 2 to the power of 3x equals 2 to the power of 5. Now you can set those exponents equal to each other. X is 5/3. So log base 8 of 32 is equal to 5/3. All right, so these next ones we're going to convert just like we did. 3 to the power of x equals 1 over 81. Now here's the thing that's a little bit different. Now we have a fraction in there. 3 and 81, that's what you're looking at first. It's the same as how we did it in number 1. Sorry about that, Lulu just went a little crazy. 3 and 81 both have a common base of 3. So we're going to write them with a common base of 3. We're going to put it in the denominator just like we have it. So 3 to the power of x equals 1 over 3 to the 4th power. And then we're going to go from there, okay? I don't want it to say 1 over 3 to the 4th because technically these do not have the same base right now, right? Because this is a fraction and this one, the one on the right is a fraction. The one on the left is just 3. However, you can move the 3 to the 4th to the top by making that a -4, okay? Because when it moves from the numerator to the denominator, that's when the exponent changes from positive to negative. So the way that we're going to write this is 3 to the power of x equals 3 to the power of -4. Now they have the same base. Okay, sorry about that. Hold on one second. All right, sorry about that. Hopefully you guys enjoyed hearing Lulu in your life. Okay, so we have the base is 3 on both the left and the right. So now we know that x equals -4. And then that's the solution there. Or I guess not technically the solution, it's evaluating that logarithm. And what you're actually answering here is 3 to what power gets you 1 over 81? 3 to the -4th power gets you 1 over 81. That's what you're doing here to evaluate a logarithm. In number 1, it's 3 to what power gets you 81. Number 2, 8 to what power gets you 32. You're evaluating the logarithm, but what you're answering is what would the exponent have to be on 8 in order for your answer to be 32. And so you can practice with this. Once you get your answer, you can, you can check your answers by taking 3 to the 4th power. See if your answer is 81. Take 3 to the power of -4. Make sure that's equivalent to 1 over 81. And for number 2, take 8 to the power of 5/3. Remember, 5/3 would have to be in parentheses, and see if you get 32. So when you would type number 2 into the calculator to check, you'd be typing 8 to the power of, and then you would have this. And when you hit enter, it should give you 32. So, but you can do this in order to check and make sure you're doing these problems right. So here we have 1/2 to the power of x is equal to 256. All right, so I'm not going to focus on a half here. I'm going to focus on that 2. And I'm going to try to write 256 to a power of 2. So I have 1 over 2 to the power of x is equal to 2 to the power of 8. Now, there's a couple different ways you could go about this. You could either make both of these 1/2 or both of them 2. I prefer to write this as 2 to the -1st equals 2 to the 8th. And now they both have the same base, right? So the left side, when you multiply your power to power, you're going to have 2 to the power of -x equals 2 to the power of 8. Now we have the same base, -x equals 8, and x is equivalent to -8. So 1/2 to the power of -8. So again, to check, you would take 1/2 to the power of -8, and does that equal 256? Okay, that's what you'd be wanting to check. So your answer here is -8. So that's how you evaluate that logarithm. I know these notes were pretty short, but like I said, we're focusing mostly on converting, and then 1 through 4, these evaluating each log expressions, are really just a review of what you guys already did in 8.2. So you want to make sure I mentioned that in 8.2 that you were going to continue that same method of finding the same base and solving that way throughout this unit. We are going to continue this. So this does not end here. So again, you really want to make sure that you understand how to convert, and you also understand how to solve by finding a common base between the left and the right side. So yeah, that's what I have for you. And if you guys have any questions, just let me know. Thanks.